consider the system of linear equation. We have three equations in three variables, and in third equation there are two unknowns, lambda and nu. Right, first two equations are given, and in equation 3 there are two unknowns, lambda and nu. These two are real numbers. If this system of linear equation has infinitely many solutions, then we have to find the number of solution of this system of linear equations satisfying this condition that x plus y plus z, this is between 7 and 77, and x, y, z are integers. Now, the general method of solving this problem is to find the value of lambda and nu using the condition that this system of linear equation, this has infinitely many solutions. We know that for infinitely many solutions, the condition is delta is 0, that is determinant of coefficient matrix is 0. So from there you will get the value of lambda, and then delta 1, delta 2 and delta 3, these three are also 0. This is the condition for infinitely many solutions, right? But if you are familiar with the basics of system of linear equation and their condition for consistency and so on, then there is no need to find lambda and nu from here, right? If this system of linear equation has infinitely many solutions, then this third equation is not any independent equation. Equation 3, or I mean in 3D, three equations in equations in XYZ, linear equations in XYZ in 3D, that is equation of plane. So if we have infinite number of solutions or infinitely many solutions for this system of linear equation, then basically this third plane, this is passing through the line of intersection of first two planes. So therefore this third equation will not give us any independent information, right? Equation 3 will be some combination of equation 1 and 2. So here basically we need to focus on equation 1 and 2. From here try to find values of any two variable in terms of third variable and then substitute in this equation. For example, you can write x and y in terms of z, or you can write y and z in terms of x, right? Any two variable we have to write, we have to express in terms of third variable and then substitute that value here. So from there we can see what are the different possibilities, what are the different integral values of these variables which will satisfy this condition, right? So for doing that, let us try solving equation 1 and 2. Let us try to write any one variable in terms of third variable using equation 1 and 2, and there is no need to calculate lambda and nu here. So if I want to eliminate any one variable, let us say if I want to get rid of z, then we can multiply this first equation by 3. That means we can write that 3x plus 5y plus, if we multiply by 3, then 3x plus 15y minus 3z, this will be 3. And the second equation, this is 4x plus 3y minus 3z, this equals to 7. And now we can do 2 minus 1, right? If we do 2 minus 1, then you can see that 4x minus 3x, that will be x. 3y minus 15y, so that is minus 12y. Z will cancel, and 7 minus 3, that will be 4. So from here we can write x in terms of y, right? We can write x as 12y plus 4. Our aim is to express any one variable in terms of other two variable. We got x in terms of y. X is 12y plus 4. Now substitute that value in any one of these two equations. Let us say first equation. So in place of x, I'm writing 12y plus 4 and then plus 5y minus z. This is 1. That means from here we'll get z in terms of y. In fact, z will be 12 plus 5, that is 17y, and 4 minus 1, 3. So this is the value of z in terms of y, right? So we got x in terms of y, we got z in terms of y, and now the given relation is that x plus y plus z, this is between 7 and 77. So that means x is 12y plus 4, then y, and in place of z we have 17y plus 3, and this should be between 7 and 77. And now let us see how many integral values of y are possible from here. So 7 we can remove, so then we have in 4 plus 3, that will be 7, and then 17 plus 1, 18 plus 12. right? Maybe we can write few more lines here. So 7, and here we have 30y plus 7, and the right hand side, this is 77. Now subtract 7 from here, so then we have 30y, this is between 0 and 70. So from here, clearly you can see that the integral values of y, because it is given that x, y, z, they are integers only. So you can take y as 0 or you can take 1 or 2, right? If I take y as 3, then it will not satisfy this inequality. So these are the three possible values of y. And corresponding to these values of y, you will get values of x from here and values of z from this relation, that z was 17y plus 3. So basically, these are the three integral values of y, 0, 1 and 2. And each integral value of y will give us some value of x from here and some value of y from here. The problem was that we need to find number of solution of this system of linear equations satisfying the given condition. So there are three integral solutions, y, 0, 1 and 2. And then x and z we can calculate. We do not need the exact solution, we need number of solution. So there are three solutions, right? So therefore the correct answer for this problem will be option C. Now in most of the solutions you will find that they will first try to calculate lambda and nu using these conditions for infinitely many solutions. But there is no need to calculate those things. You can directly start with equation 1 and 2, because if we have infinite number of solutions, then this plane 3, this is passing through line of intersection of plane 1 and 2, and that will mean that plane 3 will not give us any independent equation, right? It will be some combination of equation 1 and 2. So we can solve 1 and 2 using equation 1 and 2, right? Any one variable in terms of third variable. Here we have expressed x and z in terms of y, and then substitute in this equation, right? So from there we got three integral values of y, and hence the number of solution for this system of linear equation under the given condition, that will be 3.